Software Engineering Radio Episode 98, REST with Stefan Tilkov.
This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 10 days. Thanks to our audience and the partners listed on our website for supporting the podcast. Okay, welcome listeners to another episode of Software Engineering Radio. We are here at OOP, another conference where we interview people, because doing live interviews with the new gear is much better than doing the remote stuff. This time we have Stefan Tilkov as a guest, and we're going to talk about REST and SOA and also REST for internet applications, I guess. So Stefan, welcome to the show.
Thanks for having me here.
So, to get us started, why don't you give us a little bit of an overview what REST is and where it is used and how it fits into the picture of SOA and all that stuff everybody talks about.
Okay. So to start very briefly, REST, first of all, is an acronym. It stands for Representational State Transfer, which is not the most accessible of terms.
Right.
So this is actually mostly due to the fact that the term has been coined as part of a dissertation. So Roy Fielding, a very well-known guy in the web community, actually one of the inventors of many of the web standards, invented the term in his doctoral thesis to describe one of many architectural styles. I don't think we should dive too deeply into all of this because it leads us down, a track where many people will criticize me for using the wrong terms to express stuff. So, well, what's important is that REST is a set of core principles. REST is a set of principles that are independent from any particular technology. So you could apply those principles to any architecture that you build. If you build something purely in Java, you could build it in a RESTful way according to those REST principles. But there is one instantiation of the REST principles that is the best known, which is the web itself. So HTTP and the associated protocols like URIs are essentially based on those principles. Roy actually wrote the dissertation after the fact. So some people accuse him of doing that, of inventing something posteriori. But in fact, stealing. Yeah, but he's actually he's been involved from the start in building those protocols, and he makes a very convincing story that actually those principles have been there and have been available without that name as the core principles underlying the web.
Okay. So I just noticed that I completely forgot to ask you who you are and to introduce yourself, but I can do this very elegantly. So how is it that you deal with it? What do you do in real life? What's your job? What do you do?
So my job and the reason why I actually deal with this stuff, or I'm interested in this stuff, is that I'm actually working with a consulting company. And we focus on software architecture. And while in the past we focused mostly on single systems, on trying to find the best way to architect a mission-critical individual software systems, the focus has mostly moved now towards integration. So you no longer build a single system. Right. You always build a system of systems, and every system has interfaces to others. So I'm naturally interested in different ways to doing that. So I've spent a lot of time using Corba and other technologies, and before we founded InnoQ, which is the company I work for. When we actually founded InnoQ in 1999, we were doing Corba and Java, and then we did J2EE, and then we did a lot of web services stuff. So for a long time, I used to be a strong believer in web services.
And with web services, you mean more or less the XML, SOAP, UDI, WSDL?
Yes, mainstream SOA technology.
Right.
So what most people use for building SOAs these days. And I was intrigued by this REST thing, which I had heard of, and then I started to look into it. And there were very, very few people who actually talked about REST when I started to get to know it. One of the most vocal ones is Mark Baker, who did a tremendous service to the industry by very patiently and very, very consistently advocating the use of REST wherever possible. He tried to educate people, and when he started that, basically everybody thought this guy is nuts. He keeps on ranting about this stuff that nobody wants to use in real world. And now we found that it's generated so much interest because it turns out to be a very great thing.
I think Mark recently wrote some blog entry or said something. I read this on Steve Yanofsky's blog, who recently also converted to REST, which is a good sign for REST. Anyway, but he read something that Mark has somehow gotten demotivated or fed up with all this war against REST versus official web service stuff. So can you, before we look at REST as an architectural style and at its principles, let's briefly visit the war and what it's all about, and then not mention it anymore, just to get this theological, religious discussion out of the way. What is it that creates this conflict?
There has been criticism by the people who built the web when web services were invented. So people started inventing web services as a way to do distributed computing over internet technology. So let's use HTTP because it's deployed everywhere, because the firewalls allow us to put everything through HTTP. Let's use that to build the next generation Corba stack. So nobody called it Corba for obvious reasons. The common Corba was and stuff like that. But people wanted to have the next distributed object technology based on those things. And the web folks said, look, you haven't really understood the principles behind all of this. Listen to us for a while and first of all understand what it is that you are building upon and build on it in a way that actually conforms to its architecture. And this was basically ignored. Many people in the web standards groups and many people in the committees that actually standardize web services did not have a good understanding of what the web is about. It sounds very arrogant for me to say this, but I fully admit to having belonged to that community myself. So I was totally convinced that we need a lot more beyond basic HTTP to build distributed systems. I mean, how could you possibly build a distributed system on just HTTP? I mean, you need lots of other stuff on top of that. That was what I believed. So this war was essentially between two groups of people. One of them said, look, we know how to build distributed systems because we've been doing that for years with Corba and with DCOM and with other distributed technologies. Learn from us and we'll help you bring the web to its next phase. And then we can use the web for machine-to-machine integration. That was one group. And the other group said, look, you folks have failed. You failed to build something like the web on Corba. All your great theories just don't work. Distributed objects are a failure. They're not a success. When I use something to, when I use my web browser to connect to some web server, I'm not using IIOP. I'm using a simple text-based, a simple internet-style protocol to do that. So listen to us. We know how to build really scalable internet-scale systems. You don't. So that was the war, and that still is the war that's going on. Much of it is based on misunderstandings. So many people see advantages and disadvantages on both sides simply because they're ignorant of the respective features. So,
as in any war?
As in any war, yes. I fully admit that I'm on the REST side now, very firmly. So I strongly believe that in most cases REST is the better option. And I'm hard pressed to find good scenarios for the web services standards these days.
So then before we discuss the REST stuff in detail, it's important to just say that it is of course intended for internet style or business systems. I mean, if you want to build, just to take the typical Doug Schmidt example, right? If you want to build a network system for a warship or whatever he's always doing, then that's obviously not something you would do with REST, but probably also not with web services. So it's really not about building all kinds of distributed real-time systems. It's really about doing the typical distributed business/enterprise application or internet application.
So I would definitely agree that it's not intended to be used in real-time scenarios.
Or whenever quality of service assurances are important and that stuff, where you need those more maybe sophisticated protocols.
Maybe, yes. So I would say it's applicable I would definitely say both are applicable in scenarios where you have, where one of your goals is loose coupling.
Right.
So where you want to have systems connected, but you're not, the world doesn't stop nobody dies if the system doesn't respond in a second or in 100 milliseconds. So obviously it's not real time capable. But both styles I think are applicable in a lot of scenarios, and I think especially the REST style is mistakenly thought to be only usable in very few scenarios, and I don't think it is.
Okay, so let's look at the details of REST. You have this nice list of 5 steps or 5 building blocks. So why don't we step through those?
Okay. So the first one, item 0, as I say, is always I should actually be careful to not confuse REST and HTTP, because those are two things. As I mentioned before, HTTP is just one example, and you could build another system that is even more RESTful than HTTP. And so one should not confuse the two terms. Those are two things. But for all practical purposes, if we talk about REST, just in common usage, people are talking about RESTful HTTP, about using HTTP as intended and as described in the REST principles.
And we can maybe later briefly revisit the question what other system could be even more RESTful, or what that means.
Right. Okay. So the five things that I think are important is, the first is essentially you give everything an ID. Mm-hmm. You decide to adopt a single consistent naming convention or identification convention for all of your important things or resources, as they're called in the REST world. On the web, this ID is the URI.
Right.
So essentially, you identify things with a URI, and everything that merits to be identifiable gets its own URI. Mm-hmm. And that is a very key concept. This doesn't necessarily mean that those things have to be static, or that they have to be entities in a database or in a persistence sense. So you could have a process step, or you could have a salary increase, or you could have whatever virtual thing it is that you want to identify later on.
Reminds me a little bit of the early days of object orientation, where people initially started, like underline all the nouns and the requirements, and you have your objects, and then over time people noticed that there is additional classes and objects that you need to make the system work, and you also include those things as identifiable things.
Exactly. I agree. So you have to think of what the right resources are, and as we will see, REST is constrained in other respects. Mm-hmm. So you really have to have more nouns, more things than with other styles.
Yeah.
The second principle is that you use those IDs to link things together. This is something that we all know from working with the web. So if I put one URI in my browser and hit enter, I get back some representation of a resource. That's the terminology.
Right.
So I get a web page, for example, that contains links to other web pages, to other resources. So a representation of a resource contains links to others, and linking, the concept of hypermedia, is probably the most important concept. Of course, it builds on the fact that you have IDs for things, so that you can link them together. Yep. But this link is a very important thing, and it's not only important for human consumption. So not only if a user clicks on a link, but you can easily imagine that a program can also follow a link, and you can connect things together in new and specifically unforeseen ways. Mm-hmm. So I can aggregate things from a number of different locations together, and I don't even have to be aware of where that link points to.
Right.
So I can aggregate links to resources from different systems, which is only possible because I have adopted a single consistent identification strategy. Otherwise, it wouldn't be possible.
Which is the URI.
Right.
And I guess one of the most, let's say, widespread representations is probably XML, and then you can define a schema where one of the attributes or one of the elements contains a link to one of these other things. So that's the way how we create links.
Absolutely. I would say that even the most widespread representation format is actually HTML, because that's just
of course, for classical end user.
But, those end user applications and those machine-to-machine things are not as different as you think they are.
Maybe that's the point of REST.
That's one of the key takeaways of this whole thing is that essentially, if you have built a web UI according to REST principles, then you are 75 to 85% of the way you have already made 85% of the way towards a machine-to-machine.
But you still need the information probably to be a bit more structured, so your program can reasonably work with it. I mean, if you have just crappy HTML, that's completely polluted with layout-specific HTML crap. That's not what you want to use. So typically XML, I guess, if you build it dedicated for a computer-to-computer, machine-to-machine conversation, XML is probably more suitable, I guess.
Yes. Not to drift off too far from this particular principle we're talking about, but I think probably the sweet spot is XHTML, where you actually have a good choice. It is XML, so it's parsable by a real XML processor, by a real XML parser, and you get the benefits of having it both human-readable as well as structured enough to put in information.
And you make sure that the layout crap is factored out into CSS, so it's not completely polluted.
Exactly. So
which is good style anyway.
Yes, I agree.
Okay, number 3.
So now you have those links, you have those IDs, Now the question is, what can you do with an ID? I mentioned one thing in passing, which is that I can put the URI into the address bar of my browser and hit enter.
Yep.
And this only works because all of those resources, all of those things or objects, if you want to, all support a standard set of methods. So I can do an HTTP GET on any resource that's identified by a URI. And that's an extremely powerful concept because this GET has this GET method, this GET verb, as HTTP calls it, has a certain set of semantics defined for it in the HTTP specification. So I can, if the person who implemented the stuff on the server side has followed the specification, I can rely on the GET not having any negative effects for me. Yep. So an HTTP GET will never oblige me to anything. I will not have to pay for it. I will not have to. I won't get an invoice 2 weeks later telling me that I should get there. A GET should be safe. That's the terminology. And there are other methods, namely put, post, and delete. Those are the four core methods in HTTP that actually also have specific semantics assigned to them in the specification. This is maybe one case where we can draw the line between REST and HTTP just to illustrate the point. REST says you have to have a uniform interface, which is the same set of methods for all resources. And HTTP makes that specific and says the four methods, there are actually a few more, but the core methods are get, put, post, delete. So this particular instantiation of REST has these four methods, but it could be absolutely possible to have 10 verbs if you wanted.
And of course, if you think about that the URIs are more or less noun kind of things, then you probably will need things that create, deletes, and gets those things. So it's a natural fit to have those four. So every other REST interface will probably be more or less probably somewhat similar.
Yes, I think you're right. I've never thought about that as much, but you're probably right.
You can't do much more than something like that.
There were some things like, for example, in an earlier HTTP draft spec, there was a verb called patch. Which was actually a partial update, which is a very reasonable thing to have. And actually, a guy called James Snell is actually at the moment working on reawakening an internet draft that standardizes patch again, so that could be added. The nice thing about those four verbs is, or about any set of constrained verbs, is that you are able to build generic tools, generic clients, and generic servers that can do something reasonable with that, or intermediaries that can do something reasonable.
This thing with this limited set of verbs that is then generically applied and semantically reinterpreted, right, for all those different things you've underlined before, that's something I still am a little bit skeptical about whether this is the right approach. But maybe at the end of this discussion, I'm maybe convinced.
Yes. We'll see.
Right.
So we have 3 of the 5 things I think we've mentioned. We have the IDs, so we have a URI for everything. We have links to link stuff together. We have the standard set of methods to apply to everything, to every object. Next important point is that you only interact with resources through their representations. So a resource is a concept that you never really see in itself. It's very platonic. So you do a GET and you get back one representation of the resource. And in HTTP you have the concept of content negotiation that enables you to actually ask for different representations. So for example, if I have a customer that is identified by some URI, I can do a GET and say that I would like to have the text/HTML representation of the customer, and I'll get back an HTML page, which is exactly what my browser does when I put the URI into the address bar. Or I can issue a GET using an accept header that says I want to have application/XML. I'll get back an XML representation. And this concept is very important because it allows me to interact with the same resource in different ways, using different representation.
And that probably doesn't just extend to using different, let's say, technical data formats. You could probably also say, I want, let's say, the short summary information about something as opposed to the more extensive stuff. Or is that kind of going too far?
I would suggest to use different resources for that. So one concept, this is really, we're really entering the realm of design decisions here.
Sure, yes.
You could model stuff different ways.
So what's the best practice?
Yeah, that's maybe one of the things that are only just emerging.
Okay.
I don't think there has been any agreement on best practices.
Yep.
There is a great book by Sam Ruby and Leonard Richardson called RESTful Web Services. It's the one I recommend to everybody.
I will put it in the show notes.
Some guy made a nice joke at one of the conferences I attended lately, which was like the Roy Fielding dissertation is the Old Testament, and RESTful Web Services is the New Testament. So, I think it was Sanjeeva Weerawarana, who's one of the most entertaining critics of REST.
Okay.
So, actually, the New Testament or the RESTful Web Services book has a set of well-known best practices. Well, whether they're well known, I don't know, but of best practices. I'm not sure what it says with this aspect. My personal recommendation would be to use something like a sub-resource. This is not really a concept from REST, but I would actually, URLs can be, they don't have to be, but they can be human readable and hackable, as people say. Yep. So I would just append an identifier at the end to access the sub-resource.
Right. So you would probably still use this. So assuming you use like integers to identify the various whatever customers, then you would use the same ID for all those variations, but you would append something like summary info basic to it. Okay, I see. That makes sense, because I wouldn't like to change the actual identity identifier, the number. That kind of feels wrong to me.
Well, you have to get over your technical knowledge and forget that the ID is just the integer. I mean, the ID is the URI.
Yeah.
And actually, if I look at a customer that has an address and a history of purchases and I don't know what, a region he's assigned to and a sales representative.
Sure.
The customer itself is a reasonable resource. So I have a URI to identify the customer and I get all of the information. But the customer's address is also a meaningful resource.
And that has a different ID. Sure.
Right. And that ID doesn't necessarily have to be a hierarchical relationship to the first one. It can, because it makes it easier to understand the system.
Yeah.
But it's not as if it's any part of REST in that respect.
Sure, and there's certainly no technical requirement.
Right.
It's just a matter of good design.
Your stomach is probably right there.
Okay.
So gut feeling is okay.
It's also hungry.
So maybe the last thing that's important as a core principle is that you're supposed to communicate statelessly. I mean, it's the restriction on statefulness. This is often misunderstood because people think, well, if I can't have state, how can I ever have a database that persists something? Obviously, it doesn't mean that you cannot have state stored somewhere. There's obviously resource state. It just means that you shouldn't keep any client-specific information in a session. So sessions are totally opposed to REST's core beliefs. You shouldn't do sessions.
Well,
you should turn session state into resource state.
Okay, but isn't that in some way a little bit? I mean, if you have a highly scalable web application, the session state is persisted to a database anyway. So what's the difference?
Which exactly proves my point. I mean, the thing is, we start to...
That's what I'm saying. There is state, there is state that acts as session state from its meaning, so it doesn't matter how you implement that.
No, there's a huge difference, because if I, for example, shop at a website and I have my shopping cart, which I add things to, in one implementation, I can send you a link to that shopping cart,
right?
Because it's resource state. And I can say, look, Marcus, this is what I plan to purchase.
Because it's identifiable again.
Yes, it's identifiable. I can link to it. I can bookmark it. I can send that link to somebody else. In the other implementation, it's just, it's unnamed client-specific state. I think the original motivation for having a session state was that database actions were perceived to be too expensive. So we ended up putting that stuff in memory. And then we noticed, well, okay, now I have it in memory, but now I have this clustered system now, and I have to make sure that if the client hits another server, it has the state. So I persisted, which is absurd. It shows that the core idea was the right one.
That's actually a good point. And I've built web applications using this database metaphor myself.
So I think it's maybe, you may be doing REST, or maybe 60 or 80% of REST. You may have been doing REST for a long time just without being aware of it. It's just like, if you apply those principles, I think there are just good principles of that design. You also see many web applications, even web applications intended for humans, who violate these constraints. One example is the give things an ID constraint, so the identifiable resources constraint. Because, for example, if you look at many, especially in the Java space, if you look at many frameworks, they just give you a single URI and tunnel everything through post. So you never see a change in your address bar, and if you send a link to somebody, he'll get the homepage because he needs to build a session state, which is bad. I mean,
it depends on what you want to do. You might not, as an application designer, you might not want this temporary data to be available to others. I mean,
well, okay, if it's not supposed to be available to others, then you protect it accordingly using authentication, and that's something that you should do anyway.
Okay, yeah.
So I don't think that's a reason for doing that.
Okay.
Another thing is very important, which is that those principles are just the core guidelines, and nobody says you have to conform to all of them all of the time. So I mean, we're all engineers, and if we're building something, it makes sense to relax those constraints if necessary.
Yeah. So I guess we successfully stepped through those 5 building blocks. Let's look at why. Well, of course, HTTP in the internet is a good basis for doing REST stuff simply because it has proven that it works.
Mm-hmm.
But is there other stuff about the HTTP protocol that's useful in that context? So what are the features in HTTP that you use to build scalable high-performance applications?
Mm-hmm. So first of all, you have to be aware that HTTP is a very powerful protocol. It's a very big protocol. It's a complicated one. It's one that you and I would not design over a weekend. So it took a lot of effort of many people to come up with a thing, and it has a lot of features that many people are only superficially aware of.
Mm-hmm.
My favorite feature of HTTP is caching.
Mm-hmm.
So caching is very sophisticated in HTTP, and it's actually what makes the web so scalable. It actually enables you to retrieve a representation of a resource and in many different ways ensure that you don't retrieve the same information again unless it's necessary. So for example, you can do a conditional get, which means if you do a get on a representation and a get on a resource, you get back a representation which might feature an ETAG, which is a hash value over some internal resource state, and you send back the next get with that ETAG in a header.
Mm-hmm.
You say, okay, send me the representation if it's different from this one.
Yep.
And the server will reply with an appropriate response code that says, no, it hasn't been modified.
Mm-hmm. How does this relate to the expires header?
That's also part of the caching process. So you have different ways to control to control caching in HTTP. You can have timestamps. You can have expires headers that say for how long it is okay for a cache to hold the representation before it needs to ask again. That's a very, very sophisticated protocol. And on the web, maybe 95 to 98% of all actions are actually read actions, are gets.
Mm-hmm. Yeah.
So it makes sense to optimize for that. Maybe in an internal business application, that number is not 98%, but it's still definitely way over 50. Yes. So it's very important to do that.
Yeah.
You also have a very rich set of response codes in HTTP, status codes that actually have sense from an application perspective. Because they say, for example, this resource has moved. It's now somewhere else. Mm-hmm. Or this resource is gone, which means it was there before, but now is no longer. Mm-hmm. Or this is temporarily unavailable. This is permanently moved. This is not found. This is, in theory, available, but right now I have an internal server error. Mm-hmm. Or this is okay. Or I have accepted this request. I can answer it right now, but I may be able to do so later. Mm-hmm. So you have a lot of application-level response codes in there. You also have those methods, those application-level methods, get, put, post, and delete.
Yep.
Probably the most controversial discussion, whether those are really application methods. They are application methods on a certain level. So you could say that the most uniform interface, the most generic interface that you could apply everywhere would be process this.
Yeah, do it.
It's like, do it. And the process this has actually been popularized by Jim Weber and Savas Parastatidis, two very smart guys from the web services community. They said, we have this style called MEST. It's not REST, it's MEST. It's a message, I've forgotten the acronym, message-driven something. So it's inspired by REST and says, I only have this process this, and everything is in the message.
Basically, you have a mailbox into which you shove messages, and then the message says what it should do.
Exactly. So that's one option. But the problem with this kind of interface is that it's so generic that it's meaningless. I mean, it doesn't say anything. It just, you've essentially made it so generic that all of the meaning is now in the message.
Yes.
REST takes a middle ground. It says, I have some level that is generic across all resources in all applications, which is that there are certain things that are merely reads. Those map to a get. There are certain things that update the resource. They affect the resource they are applied to. You map them to put. There are certain things that lead to the resource being gone. which is a delete. And there are things that rely on post, which is essentially on the one side create a new resource. So it doesn't necessarily affect the resource it's applied to. It might create a new resource. And post is also the generic cop-out method. If you can't find anything else, you can always map it to post.
Yeah, and I mean, it is a limitation to have only those 4 verbs.
Right.
And that means that you either have to misinterpret them in some cases, or you have to come up with artificial nouns, artificial things to be able to address them.
Yes, that's the point we had before, right?
Yeah, right, exactly.
I disagree with that. I would actually try to convince you that you have to think of it in terms of object orientation and inheritance. So what you actually do is you derive your application-specific interface from the REST application interface, which means that you have to take care not to violate the semantics associated with those 4 things. It's the Liskov substitution
you can specialize.
Right? So you specialize. And it's perfectly fine as long as your resource conforms to the HTTP resource protocol. It is a valid HTTP resource.
Sure.
It may also be a valid Markus Völter resource, a Völter.org specific application resource. So if I'm a client, I can actually be a client on 2 levels. I can be a generic client, I'm curl or wget, or I am a web browser. Then I can interact with your resource based on my knowledge of the HTTP specification. And that's also true if I'm a cache, for example, or if I'm a proxy, or if I'm the Apache web server, or any of the other tons of reasonable and very well tested and efficient web software pieces. If I am a specific client to your application,
then you know what it
then
means.
I know what I actually do if I invoke one of those methods. So I agree that is a limitation. You have to design differently. You end up with more nouns instead of more verbs. But you gain something, which is obviously, I mean, you have to have a good reason to accept limitations, which is that you gain this widespread, generic applicability. You actually become part of the web instead of tunneling and stuff through it.
Right.
Let me just add to that. That's the one major point that the web folks have criticized in the web services approach, because the web services approach tunnels everything through post. So that's not true for SOAP 1.2 in theory, although in practice everybody still does it. So in SOAP 1.2 you can do differently. In practice everybody does that. In practice you also have the concept of an endpoint, which is that you identify your application with an ID, and then you have a set of methods in your service that sits at that particular endpoint. So essentially you ignore much of the aspects of HTTP, which is only, I mean, you have to, because web services are supposed to be agnostic to the protocol, so you cannot exploit HTTP, but there's simply no way to do that. If they're supposed to be able to run over TCP,
or
you cannot
messaging
use
middleware.
Right, you cannot use any of the features of HTTP to do that. So there's simply no way to consolidate those two worlds.
Sure. Anything else about the HTTP protocol it's worth mentioning?
Well, I have to say that it's supported everywhere, absolutely everywhere. I mean, every client, every library, every programming language has support for HTTP. It's extremely well tested. There's some great software. For example, I would say that the HTTP server, the Apache HTTP server, and the Squid proxy cache are probably light years ahead in terms of, or years ahead in terms of quality and efficiency and maturity, as opposed to any ESB you can buy today.
Probably,
that's software that runs half the internet, half the web runs on Apache HTTPD. So there are many, probably lots more. Just to mention some, you have built-in compression capability. So the client and the server can negotiate whether or not to compress the stuff. You can chunk data transfers. So there's no problem downloading, if you have the bandwidth, there's no problem to download a 1.2 gigabyte Oracle installation image over HTTP. You don't do that over web services, and you don't do it over Corba. So there's a lot of things that just work and that have been established over the course of the time of HTTP.
So let's look at the little sample application or a sample case study and contrast the web service approach with the REST approach, just to make things clear. So I guess the example is the usual order customer stuff. So why don't you outline the solution that you would do with Corba, web services, WSI, whatever?
Let's just imagine that you want to have a system that handles orders, and you'll typically have a order management interface. It's the order management service.
Yep.
And if you do a CORBA style interface, or if you do the typical web services mainstream style interface, you'll have multiple operations in this interface. And these operations are specific to the task at hand, right? You want to build an order management system. So you have one method that accepts an order. Let's call it submit order. And as a parameter, it gets an order object, and it gives you an ID.
Yep.
Which is, of course, a proprietary ID in the scheme of your order management system, right? It'll be 4711. That's the ID you get back if you submit an order. And then you have to pass in that ID if you want to inquire about an order. So you have a get order details, and you pass in the ID of the order and get back an order object or an order XML blob, whatever. It doesn't really matter. So you have those operations. Let's say submit order, get order details, list all orders, delete or cancel order. You probably don't want to delete. You want to cancel
mark
it.
As deleted.
Mark it as deleted, whatever. So that's a typical approach. What it means is that you end up with such an interface for every specific application that you build, which is exactly what it's designed for. And you also typically have some sort of description language, which may be code in the case of RMI, or it may be an IDL, as in case of CORBA or DCOM, or it may be some WSDL file that says this is the way I describe it, with XML schema and with the stuff that WSDL adds on top. Now, if I map that same scenario to a RESTful HTTP approach, I actually end up with more nouns than verbs. So I will have orders, and every particular order will have its own ID. So the ID concept that is proprietary in what I just described will become the mainstream ID concept, which is URIs in the RESTful HTTP approach. I will also find nouns for the collections of orders. So that's one of the typical best practices, right? It's not part of HTTP or part of REST, but it's something that has been established over the course of time. So I'll have a collection resource that has all my orders, and I have another collection resource maybe for my customers and for other stuff.
It's just like Eric Evans stuff, right? He has a repository for stuff.
Is that the domain-driven development guy?
And you have the things themselves. You have entities and repositories, and both are things, objects, and here in this case they're both resources. You can interact with the collection or with the single thing.
Right. It's a composite pattern. So in this case, I think so. Every collection resource is also a resource and can contain resources. Definitely, probably that. But I don't know the DDD stuff that well, so I can't really comment. So you have more nouns now. You have in the case of the first service, the order management service, you would have a single URI if you deploy it as a web service. In this case, we now have an unlimited number of URIs because every order and every customer and every other object in your system has its own ID. And now we have the methods. So now we have something like submit order. How do I submit order? Submit order. If I try to find the matching method in the HTTP application protocol, would be a post. Because typically I use a post to create new resources. And the target of that post, the URI that I post to, should be the containing resource, which in this case is pretty obviously the orders collection. So I post an order to the orders collection. I get back in a location header the ID of the newly created order.
In the example you have here, we're actually reading this from a bunch of slides, cheating here. You have also this hierarchical URI where you express that there is a bunch of orders for a given customer. So the URI would be /orders and then /customers and then /the customer ID and then /orders. So that's exactly this way of hierarchically providing more details about things.
Although I have to warn against, one of the things that many people start when they adopt REST is they become fanatic about URI design, and they spend 10-hour design sessions on coming up with the right way to structure your URIs. Now, I love readable URIs. I think that's a great thing, and I love hackable URIs. So if I look at the URI in the browser, it's great if I can just cut off the last segment and get something meaningful back. They're hackable and that's good. But that's not in any way as important as many people think. It's good to have readable URIs, just as it's good to have readable class names and readable variable names. But you shouldn't get too fancy with that.
Okay.
So there's a huge difference between those two things. In the one scenario, I have a service deployed at a single endpoint, and the value that I add to the web is essentially one URI that I can post to. And I can only post to that if I know exactly what application specific is behind that. There is no way for a generic client to make any sense. You could build a generic client if you have the WSDL. You could generate some UI that could, but it's like I try to become part of this great big web, and I just hide everything in this great room behind the door that I can only go to if I have the key for it.
Yeah.
You know, that's the model.
Yeah.
If I have the REST approach, the RESTful HTTP approach, I add a gazillion new resources to the web that can be linked to. For example, I can send you an email and include a link to an order.
Yeah.
I can build a web page, an HTML page that has that.
I guess here's my point. If you build a system that is intended to be used on the internet and integrate with the internet so you can send links to resources using email, then obviously using the RESTful approach is better for the reasons you outlined. I mean, there's no arguing about that. However, if you build a generic distributed system that's maybe not on the internet, that's used within an organization, maybe not even this enterprise-wide thing, maybe it's just a flight management system which connects info terminals and the data backend or something. Why is this an advantage that you are integrating in some way or shape or form with the web? I don't see an advantage there.
Well, it's a very good question. I would argue that organizations internally more and more resemble the characteristics of the internet. So they become combined in new ways. They restructure. You have mergers and acquisitions. Things change all the time. They become, the business becomes loosely coupled because you cannot rely on the same people being there on the next floor, because they might work for a different company, or their work might be offshore to India tomorrow. You have no idea what happens to your company. So it's a good thing to build for loose coupling, as the internet does. Another thing is that. That was a very good point made by Pete Lacey, another well-known REST guy, in one presentation I recently attended, which was that people, as with the PC revolution, people become used to certain things in private or in external use, and then they carry that to within the enterprises. So the fact that I can do a Google search and find information on the internet might make people think why it's so hard for them to find information in their own company. So if everything were exposed as a resource within the company, never mind the internet, just within the company, and you have a single Google appliance that can work because everything is exposed as a resource, everything supports a GET, and everything returns a readable format, then you could actually do a Google search across all of your company's information systems. You can use Microsoft Excel to pull in an HTML table from resource and do calculations on it. So there's lots of benefits that you gain from that.
So your point is basically that there is no point in distinguishing between an enterprise system and the internet because both are actually solving the same problem, and so it's good to consider the enterprise a web-like environment.
Right, to a large degree, I think that's true. I mean,
there's security.
Yes, there are issues. I mean, yes. Some things are even easier. If you're within a company, it might be easier. You don't have to defend yourself against those denial of service attacks. But who knows? Maybe that's going to be a problem within the company as well. Yeah. Maybe not as intentional, but you might end up with the same kinds of attack.
Yeah. So I think we discussed the building blocks of REST. Let's summarize why people should care. Why is it that people should maybe actively try to learn REST or inform themselves about the differences between the two approaches? How do you become informed, and why should you?
So first of all, I think that the RESTful approach has proven to be very, very scalable, very useful, very successful, simply because this is simply shown by the web's success. I mean, if you talk to somebody 15 years ago about the goals of the web, everybody would have told you that you would be crazy to expect this to work. And it works very well. We're all relying on it. It has really been a disruptive change within the way we use IT systems. Yep. So I think that let alone is a good reason. Another thing is that even if you end up building your system-to-system communication using web services, maybe for political reasons, because you have no other option, or maybe because the tooling and the skills of the people you have is just supportive of this and not as supportive of the rest stuff. Even if you do that, being aware of the REST principles will make you build better web applications for human consumption. Because many people just don't know about these things. They use a GET to change something. It's a bad idea. If I link to that resource, I'm not really linking to a resource. If somebody follows that link, they'll invoke an action. That's something is wrong there. People just tunnel everything through post because they're not aware of any of this. So even if you only do it for that reason, it's a good thing to do that. I do believe that the main argument is that if you look at the history of distributed computing in the last 15 to 20 years, you can see that there's always been this goal of this ubiquitous system of this set of principles and technologies that's available everywhere, so that everything can connect to everything else.
Yep.
And I don't know, you probably remember those O'Farley Hake Intergalactic Web of Objects Corba books. Do you remember
I do. Yeah.
So that was the first time when I read them, I loved them. I thought this is the great vision. I can have any object on the planet talk to any other object on the planet, and we all know how that turned out with Corba. It may be because of political reasons, but still, it never worked out the way people envisioned.
Sure, but I mean, there's two different problems. I mean, one problem is that the fine-grained object kind of stuff simply doesn't scale. So even if you build a system with Corba, people don't build distributed objects anymore. They build distributed facades, or whatever you want to call this, stateless typically. So that is an architectural insight that has, that just everybody knows about. So that's not specific to REST or anything.
I agree. What I wanted to say is, though, that the vision that those folks had back when they were total fans and had drunk the Corba Kool-Aid, that vision actually is much more realized in HTTP than in any of Corba's successors. Because I really can now access any resource on the planet. I can call it an object. And actually HTTP has much similarity to object orientation.
Yeah, the nouns.
The nouns. And it has the standard set of verbs that's not common in object-oriented systems. But it also relies on the internet style way of doing protocols, like text-based and very simple, very easy to understand. And I think it's actually proven that this is a very good way to build those things. So I think it's definitely worth a closer look, and we've seen great success in building systems.
So what do you do if you need transactionality, security, and all that stuff, where in the WS star land you have all these fancy standards? How do you compensate for not having those things in a REST environment?
So first of all, let me say that I'm guilty of using the term WS Death Star, which has been invented by David Heinemeier Hansson. I have to admit, though, that since I've used that a while back, the universe with the web services standards has become much more reasonable. So the many standards are now gone, simply have been consolidated. So it's much better than it was 2 years ago. I'll definitely concede that. But still, I think that many of the standards, although pretty good, for example, the WS security standards are not bad at all, are simply not used in practice as much as people like to believe. So, for example, there's a good case to be made for message-based security, which is supported by WSS. But in practice, it's often way too expensive and not worth the effort. So people use SSL.
Yes.
People build web services and use HTTP and SSL and HTTP basic authentication, which is exactly what you'd use in a REST-based approach too. So there's not really a difference there. Transactions is another good example. I think transactions in a loosely coupled system are generally a bad idea, especially, of course, if you're considering the atomic kind or 2PC kind of transactions. There are other transaction protocols, compensating transactions, things like that. I'm not a big fan of putting that into infrastructure. I think that's application logic. So I've never run into that transaction problem as much, because I think you have to think about
if
loosely coupled connected systems differently.
In loosely coupled systems, there isn't much infrastructure can do. I agree.
Right. So, I mean, some people disagree. I'm open to debate here. I'm not advocating that. And if you have, for example, a case where you need to integrate existing systems that support 2PC transactions using OpenXA, you may be better off using something else than REST. That's also a very important point. There's lots of cases where RESTful HTTP is not the best option. But I'm doubtful whether the alternative should then be web services.
Absolutely.
Sometimes Corba might be a better solution because you have an existing Corba system. Sometimes a JMS, a messaging system.
That's what I meant. I think there is no point in trying to play REST against. I had the extreme example with real-time quality of service enabled Corba.
I agree now.
Or if you go back to, let's say, messaging backbone application infrastructures in a big enterprise, REST is really an alternative for cases where you would use WS star stuff. That's what you should contrast it to.
I know, I understand. That's perfectly reasonable.
Okay.
Right.
So before we wrap up this thing, I would like to ask one thing about tooling. You mentioned it before in passing. There is all those web services tools where you pass in a WSDL file and it generates all those, stubs and stuff. So what kind of tool support is available for REST? And maybe the question I should ask before, how much tool support is actually necessary, considering that it's internet protocol based?
One of the nice things that has happened in the last few years in the web services space is that two concerns with regards to tooling have become separated that were merged together before, which is the separation between the actual invocation and the data binding. So earlier versions, especially in the Java land, had a single approach for that. Now you have with JAX-WS, with a successor to JAX-RPC, you have the choice of using your data binding. Basically, any Java web service tool could allow you to do the same thing. You can use any data binding. And of course, you can use exactly the same data binding tools with REST.
Yeah, assuming you do XML, because most of these data binding tools are XML.
Yes, but you also have data binding tools that allow you to do JSON to objects and back. So it's really, if you're a fan of data binding, and I'm not, if you are a fan of data binding, you can use the same tools in both worlds. You can the same thing. So the question is, do you need something that generates a stub for you that has submit method? I mean, you know, the difference, it's not that big a difference anymore.
You don't have those methods anymore. They're just called get post.
Yes. In RESTful HTTP, you use the same methods all the time.
So you can have a generic submission interaction thing.
That said, I'm actually I'm actually a member of the expert group on JSR 3.11 in the Java space, which is the Java API for RESTful web services.
Okay.
And that's an API that is in typical current Java fashion annotation driven, and gives you a very easy way to expose Java objects as RESTful resources. And in contrast to many other standards in this space, it's been done by people who really understand REST. I'm not talking about myself, talking about the other guys there, who really understand it, and who are trying to avoid all the typical mistakes. And even Roy Fielding is involved with this, not actively, but he's doing all of that and making sure we're not doing anything dumb there. So I'm not that big a fan of annotations in Java, so I have my problems with that as well. But still, I think it's a good way to enable mainstream programmers using the mainstream programming language to easily build systems that conform to those constraints. So I think the tooling is getting better, and even within the web services space, where you have that much tooling, you often end up building worse systems because of it. So I'm skeptical of any sort of tooling anyway.
Okay, so let's wrap up this episode maybe with summarizing a couple of important takeaway points. Why don't you just do this? I guess you know what they are.
Okay. So one of the things is that many of the promises of the web services on WS Star space, I think, are questionable, and you should really ask yourself whether these are really things that you need and things that are really that you really gain some benefit from. So my favorite example would be protocol independence, which is something that is so leaky. You know, you're not abstracting over your protocol at all. If you've ever tried to build something that works equally well over JMS and HTTP, you'll find out that this protocol independence is not really that true.
Yeah, I think that you need to distinguish between abstracting away the protocol as an implementation of an interaction paradigm and trying to abstract away the interaction paradigm. You can't do that. You cannot.
Exactly. That's exactly the point.
Exactly the point.
Absolutely.
Right. So you have to.
JMS is so totally different than HTTP. Maybe.
Right. But you can abstract away messaging infrastructure, the one you choose, and say you have.
I agree.
You just know it's messaging.
Yeah, I know. But if I just know it's messaging, I can use JMS. I mean, that's an API I could use.
Yeah.
And
I have customers where they have different languages and they can't use JMS all that. But it doesn't matter. Anyway, just go on. I don't want to spoil your.
That's no problem. So the first thing is there's a promise associated with web services that I think is questionable, because you can either use the stuff that web services are supposed to encapsulate, or you can go down the full RESTful HTTP route. I mean, after all, web services are supposed to create a single, widely deployed set of protocols that everybody can use. Personally, I would rather use a set of widely deployed protocols that's already there than waiting for another one to become available that adds no value for me. You know, it's like I think protocol. I think that's also a Mark Baker quotation. I think protocol independence is a bug and not a feature.
Yeah, I saw that before. Yeah.
The next one would be I think it's perfectly fine to standardize on standards. So many people are afraid to standardize on HTTP, which I don't get. I mean, you don't become dependent on any single vendor. No. You pick a standard and stick with it. It's like wanting to abstract away whether you store your data in an XML database or in a relational database or in flat files. I mean, sometimes you have to make decisions, and you shouldn't be afraid to make decisions, and you just pick one of them. And it's perfectly fine to do XML over your messaging system of choice. If you have decided to use, WebSphere MQ everywhere, which is something that many companies do, why would you want to abstract that away to no benefit? It doesn't really give you much. And maybe the last thing is, I think you should really understand the web's architecture, even if you later decide not to use it. You should understand it. And my obvious recommendation would be you should understand it as well enough so that you can exploit its benefits. For example, all of the scalability things, the interoperability, the caching, chunking, compression, all of that stuff, I think it really leads to you being able to build better systems.
Okay, very good. So is there anything else you want to say, pearls of wisdom you want to leave with our listeners, as the guy on the space show always says?
Pearls of wisdom, I don't know, but maybe one of the things is that I'm really happy that I think it's now starting that we're moving beyond this versus that war. You know, it's like this has not been very, very productive. I think it was necessary for some time to make people aware of REST.
Yes.
Now they are, and now I'm really happy that we can move on and actually try to come up with those best practices that you mentioned with typical solutions to typical problems, and I'm really looking forward to the next few years in that regard.
Very good. Then I thank you very much for being on the show.
Thanks for the time.
Thanks for listening to Software Engineering Radio. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example, by clicking on the Dig, Reddit, Delicious and Slashdot buttons. To contact the team, please send email to team@seradio.net, or if it's specific to an episode, please use the comments facility on the website so other people can read and react to your comments. This episode of Software Engineering Radio, as well as all other episodes, are licensed under a Creative Commons license. Please see the website for details. Thanks to Charlie Crow and the PodSafe Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.